And that is the best advice that I can ever give anybody regarding anything ever. Cool. All right. So I like your idea. Let's just notice that all these are just going to move. So anywhere that there's a power, and then if you're okay with it, I would also suggest doing one more thing. Could we rearrange stuff? Like, does it matter what order I add stuff in? So if you're not sure, because I only heard one person answer, if I give you this problem, 2 plus 3 minus 1, can you guys do that problem? What is it? 4? Oh, but okay, well that's very much the same or different than this. So we can change the order, right? Now, there's something in here that I don't love, and maybe I unintentionally just circled it as I was going. This one feels to me like it's out of place. Why, Hazel? Because you seem to agree with me. Like, it should probably be with the adding, right? Like, because I know that the addition stuff is going to stick together, and that I know subtraction stuff will eventually stick together as well. I'm just going to rearrange them and do the powers in one step. Okay, so this one, you guys said is ln of what? X squared. You say y? Okay, so you're even doing more than I'm just going to take little steps. But I'm okay with that if that's what you have. You just skipped a line. Plus the natural log of y squared. And then I'm going to move this one. I'm going to rearrange it. I'm going to say plus the natural log of, what's the next one? W cubed. And then I'll just write it the way it is, minus the natural log of z, and minus, do you want me to write it as a power? Okay, natural log of what then? X to the 1/2. What does this mean, just as a square root? So if you would rather use a square root symbol here, I have no issue with it. Okay, have I done anything anywhere that you guys disagree with? The rearranging you might not have done, and that's okay. But let's go ahead and just look. These three, do they combine somehow with the log properties that we discussed? Nope. With the log properties that we discussed yesterday. If there's addition between them, what happened in the argument? Multiply. So there's more than one way to go through this problem, but any objection to me just shoving these all together in one single logarithm? Okay, what do you want me to write here? X squared, y squared, w cubed. I'm good with that. Okay, deal. Now these ones, we have a couple options, and I wish that I could say there's always one way to do it, but there's legitimately like 10 different ways one might think through this problem. I kind of have to try my best to meet in the middle because I would do this in one line, and some of you can probably do this in one line already too. Some of you would do it in way more work, and we have to kind of split that difference. What do you guys think we should write on the next part? And somebody that hasn't chimed in, not because I don't like your opinion, but I would just like to spread the love around. Addison, you were avoiding eye contact. What do you want me to do with these?
ln x or ln z x to the on the bottom.
Okay, so I like most of it. Okay, I'm going to make a mistake real quick. And Addison, this is just so you know, like you did make a mistake, but it's such a common mistake. There's like 3 things that are really common to happen. I'm going to do the wrong thing, and I think it's what you said, but I might have misheard. Okay, if it is a wrong thing, I love it nonetheless because this is a common mistake. Do not write what I'm about to do in yellow, okay? Addison suggests doing this, I think. Is that what you were telling me? And what do you want me to write here then? So just like this? Okay. This feels pretty close. Now, you are wrong, and that is okay. With this, I want to make this really clear. Remember the mistake that I had on the board a minute ago with the ln of x plus y does not expand? Notice what happens. If we have a subtraction, where and only where does the division occur? In the what? We're going to try that again. Davian, nice answer. And there was another whisper somewhere. But do you guys agree that when I see the subtraction between these logarithms, the division that we're after is only the argument? Okay, so I want everybody, like, it's cheesy and it's kind of lame to do, and I hate it when people do it to me, but I'm going to do it to you right now. Where is the division if log subtract? And I need everybody to answer this. The argument, only in the argument. Is our division only in an argument here? No, this, if you look at the notes from yesterday, is more like a change of base. This is not the property, although you're certainly on the right track. Now, to avoid this, there's a couple things that we can do. And anybody else guilty of that same mistake? For sure, lots of people will be. There wasn't a whole lot. I'm not going to say names. Thank you for volunteering. There were 3 other people in class that just with a quick glance up made the same mistake. Everybody makes this mistake. Here's my suggestion. 2 ways to do this. Either we can take it and just work left to right, or could I factor a negative out? Now, if I do this, and I don't really care which way we go through it, but if I factor out a negative, this is what I'm left with. And I think this yellow part feels a little bit easier to clean up now. What happens just in the yellow part? They're adding between the logarithms. What does that turn to? Everybody agree that it's multiplying. So we still get this natural log of x squared y squared w cubed minus, and let's condense these 2 down to a single expression real quick. The natural log of, Leilani, what goes on the inside of this logarithm? Zx to the 1/2. Now, if we wanted to change to a radical here, we could. What gets the radical around it? The z and the x, or just the x? Just the x. If I wanted, notice there's no 1/2 on the z. There's no 1/2 on the z here either, unless we were to put parentheses around this. There aren't. It's just the z that gets the square root. Okay, sorry, just the x. I'm sorry. That was an absolute terrible mistake. Now, from here, if I see subtraction between them, same question. Where does the division happen? In the argument, which means right now we're all the way down to 2 logs. Can we make it just 1? This is the natural log of, what's my numerator? X squared y squared w cubed. And we're dividing by what, Casey? Good. Or z root x, if you'd rather keep it as a radical. Now, these problems, and this is probably one of the bigger times, we didn't do a single thing like this yesterday, did we? Now, I try my best to never just say good luck and do it, but if I had to, did we learn anything new just now? You think so? And maybe, like, good, that surprises me. I was not expecting a yes. So let me rephrase the question then, because that makes me feel good, so thank you for that. Did we use any knowledge that we didn't have already? Like we just used those 3 properties that we covered yesterday, right? Now in mathematics, especially in higher level mathematics, it's inevitable that this happens. In Algebra 1, the problems are straightforward enough that I can say pretty much with anything. Step 1, here's what you do. And then once you've done that, here's step 2, and here's step 3. When we get into higher and higher level mathematics, and you'll start to see it, you probably saw it a little bit last year, you'll see it more this year, you'll see it more next year. All that we can do in here is make sure, or that I can do rather, is give you guys all the tools and show you like the basics of how to use them. It's like if I teach you how to use a hammer or a drill and a screw, and then I say put these pieces of wood together. If I've shown you how to use the drill and put a screw in it, is it reasonable for me to say now drill 2 things together? Like that's an easy analogy to look at. I probably wouldn't teach you how to use a drill and then say now go use the planer to do this. Like that wouldn't make sense. But anything related to drilling that just requires you using the drill, you should be able to do, or reason to figure out. And it might sound like hopefully it doesn't sound like I'm being aggressive and telling you guys like anything that you're doing wrong. You're not. Just be aware that like this is going to keep happening. I can give you the tools. We just won't have time to do every type of problem. You guys already do it better than any other class, and you continue to do it better than any other class that I've ever had. Your questions and your awareness of where you're at is awesome. Keep it up. Love it. Let's do more of these. All right. So do you want a quick log break? It's not a brain break per se, but do you want a log break? Okay. 2 little things. I guess several things. So yesterday in our pre-calc lesson, we were expanding logs. I've been looking for this for like 3 weeks, and I just saw it, and I'm sure I've seen it and just didn't remember I was looking for it. That's exciting. All right. Do we want to do another example of expanding? Okay. So we'll do one more expansion, and this is example C. Is that correct? Okay. So let's see. Dolan got it. All right. I don't know. We're expanding, right? Natural log of, let's see here. I want the fourth root of x squared times y over z. You are expanding this logarithm to be multiples. Now, yep, that's it. I'm just going to leave it to you guys there. Together, do you want to work at your desks? Okay, I'm going to give you a 30 to 40 second head start. Talk with your neighbors because I'm going to call in random people. If you're not sure at all where to start, this would be a good time to work that out with your neighbors. 40 seconds from right now. So 45. We're right at 12 minutes. I'm going to call in somebody random. 45 seconds of awkward silence. Suggestions. If you're wrong, I'll try to do it in the gentlest way, but we're going to fix it. I like it. What do you mean get rid of it, though? I would call it the 1/4 because it's the fourth root. But absolutely, when we think of this, if I write this as our order of operations, do you guys know what this one stands for instead of PEMDAS? Grouping, exponents, multiply, which the only reason that we can simplify it is because it's addition and subtraction of this, or sorry, multiplication and division are the same. And this one is subtract. Now, you might call it gemma, which I think makes more sense because addition typically is the one that we think of first. But subtraction and addition are also the same thing. So this works. If we go through here, the grouping one is always kind of a weird question. And what I've started doing in calculus, because we're having to worry about where would the groupings be if we wanted to put them. If you were to try to type in the argument into a calculator, where would you need parentheses? And I guess your calculators don't really need parentheses. If I wanted to use to the 1/4 power, what would get parentheses? All of this, right? Okay, so when I'm going through these problems, this is always present in my mind. I'm thinking about order of operations stuff and what should I do first? And the fact that there's a grouping that coincidentally winds up being an exponent in the end, that's the first thing that I see when I look at this. So I'm going to use Matilda's suggestion, and you're absolutely right, Matilda. I'm going to change everything in here to the 1/4 power. Now, I might do more than this, and can I write this in a less silly looking way? Should I write x squared times y over z? Or is there like a more natural way to write that? Can I rewrite this, just this term? Like I'm going to do something to the 1/4 for sure. That's my first step. But I would probably do this. Is that the same thing? X squared y over z? If I had this over 1 and multiplied, is that just what I get? Yep, this is a much nicer way to see it. And it's the same thing. You don't really have to rewrite it, but in my mind, this is what first thing I do. All right, now that we've got the power taken care of, number 11, what's up?
I think it's in my last step that I did like the 1/4. I distributed it so I could put in the
Okay, so we'll check our answers at the end. It's okay if you did it at the very end. I think you're going to have to do it before the very end. Okay, so you did 2 steps in one. Can the 1/4 go out front? Yeah, that's what powers do, right? They just move. Okay, and then as I start going, I'll do one line at a time with the understanding that you guys might do more than that. What is the argument still? Okay, so now I'm going to keep kicking back to that question, and we'll see if I can get it to work. If you were to type x squared y over z in your calculator, are there parentheses, or is there grouping involved here? I want to challenge you real quick. On your calculator, we'll try to do a different one. I want you to do, it's going to feel weird, but we're going to make it plus. I want you to type in 2 plus 4 over 6. And if you type it right, I think the answer will be 1. But I want to see if anybody types it wrong. And just so you know, I'm cool with wrong answers. The wrong answer is going to be 2.67. Somebody in here got 2.67? Okay. We have two answers. 6 is correct. Sorry, 1 is correct. 2.67 is wrong. If I just type it in key for key like this on my calculator, what's being divided? What needs to be divided? So in this situation, if I just asked, where would you put parentheses? We all agree it'd be here. Now, multiplication is kind of wonky because it doesn't really matter in the end. But can we apply that idea and say that there is really grouping up here? Like, and I would always encourage, think about grouping in your parentheses of like ugly fraction stuff, because there really is grouping. There's a whole top over the whole bottom. We just don't put the parentheses because it's unnecessary. But by recognizing that there is grouping, when I look through this, I think, okay, if there's grouping, how do I deal with it? And this time that grouping is indicating that there's division, right? So what happens with division? So they subtract, right? Now, this 1/4, everything gets it, right? Which means that 1/4 has to be connected to everything. I'm going to use a bracket just as a style choice. You could use a parenthesis. I'm just not going to distribute it until the very end. So let's just split up the natural log here. This becomes a subtraction where the first part is what? And we're going to do it in small steps. Can we agree it's x squared y for now? Minus the natural log of z. Now, for somebody, like when I said natural log of what, I heard x squared, and I can tell, and I think it was Dolan, that he's just working a little bit ahead. Because Dolan recognized that what's going on between these? They're addition. So I have no issue if you skip lines, as long as we're all on the same page with, if you skip lines of work and I can't see very clearly where your mistake happened, then I can't give you the parts that were right. Like I just won't give you the partial credit, so be careful. How do I expand this? Natural log of, now I could write x squared, and I will. Could I just move the 2 to the front right now? And you can. I'm going to write it like this. I don't mind if you skip that step, because I'm going to do it in this next one anyway, minus the natural log of z. And we're just going little by little, right? Step at a time. Did anybody do this many steps on your own? And that's okay. Totally good with it. There's only 2 more things left to do, but I'm going to make it happen in one line. Where does this 2 go again? So I'm already imagining it in the front, and then anything else distribute through everything. That was a question. It might not have sounded like it. Is there anything else that distributes to everything? So in my head, I already have 2 out front. What's 2/4 when I distribute it? So we get 1/2 the natural log of x, because the 2 moved out and it became 2/4. I've just simplified. Plus 1/4 natural log of y minus 1/4 the natural log of z. And we're done. We have completely and entirely expanded this thing out. Now, there's always weird situations here, and we'll see them, but we are expanding. Yes, sir. We don't. And the reason that we don't is because right now, if we started going the other direction, which we can do that, and we can just start with this one. So we're going to do one more example right now, and this is like the last, I don't like that color. This is the last example today. You guys will have time to work on some stuff. We might do a couple, but it's the last example named. So before our example was expand, right? Let's condense. And I'm not going to say a whole lot about this because all it is this is expanding. We're just going the opposite direction. It's like we're working backward. So the cool thing is that I already know what this is going to come to because I can see up top. Now, I'm going to challenge you with a piece of paper, with your hand, or just don't look at it. Try not to look at where we started our last one, and we're just going to immediately do this. So here we go. A, I want us to condense down to a single logarithm, which is what we did on our bell ringer today. We're going to do this one. 1/2 x, just kidding, 1/2 natural log of x, plus 1/4 the natural log of y, minus 1/4 the natural log of z. And again, we know where this is going to wind up, or at least we have the answer and we can check it. But I don't want to just look at the other one and say, well, how do I just undo it? I want to actually build it up and see if we can't start the process. Now, everybody has a different preference. Some people prefer to condense. Some people prefer to expand. They're really the same thing. But for whatever reason, I prefer to condense. It's easier in my head to look at this because as I'm doing these, I'm just going to work left to right. Now, you guys will all be able to do this in one line here pretty quick, but let's check. Is there any obvious properties that we can use right here without looking at the last example? The fact that there's numbers in front, tell me something. So there is a GCF. Maybe you could take a 1/2 out of them all. If we didn't want to do that because it might not be clear to everybody, or maybe there's a different property. Anything else that we could do? The fact that there's a number in front means what in the properties? I just didn't hear what you said. What gives us a number in front? Could I move this to be the natural log of x to the n? So could these just move in? Like in my mind, David, I like the thought of the GCF and I love that, but it's not the natural thought in my mind. My first thought is, oh, it'd be natural log of x to the 1/2 plus the natural log of y to the 1/4 minus the natural log of z to the 1/4. Okay. That is my first thought. Davian, you can do the other one, and as long as we get to the same answer, I'm fine with it. But any objections with using that? All right, this is super exciting stuff, I can tell. Karina, what happens with these two? Okay, now, I'm good with that. I'm just going to write x to the 1/2 and y to the 1/4. Here's where these problems get shorter, and if I'm going way too slow, please don't hesitate to tell me. We all know that these are going to multiply. And I know there's going to be x to the 1/2 times y to the 1/4. What's going to happen with this one? And only division where? In the argument. Can I do 2 steps in one here? Okay, good. What's the numerator going to be? What got multiplied? Y to the 1/4. And then we're going to wind up dividing by what? Z to the 1/4? Okay. Z to the 1/4. Now, at this point, we have condensed down to a single log. We can clean it up and change a little bit. The only weird part that's going to happen, and this is what the GCF might have helped with, is I noticed that it's a 4th root of y. That's what the 1/4 is. And it's a 4th root of z. But I can't really write that together with a 4th root of x because it's x to the 1/2, right? Now, if you stopped here, you would be good, just so you know. But just so we can see it, if I wanted this to be a 4th root, can I write 1/2 as a 4 in the denominator instead? And it would be, instead of 1/2, how can I write it with a 4 downstairs? We all agree this is the same thing as 2/4. Now, I'm just going to make that note off to the side. I'm not going to rewrite a whole line. I'll just say, check it out. This is the same thing equals x to the 2/4. And the only reason that I would ever even think about doing that is because I realized that these are both to the 1/4. Like, I just want to make them match, which means I could write everything as a 4th power. Cool. So let's do that. The natural log of, and everything is now a 4th root, which means does anything need exponents anymore? This one does. This is 2/4. Here's the 4th root that came out. What's still stuck to the x? A 2, and we just have a y, right? And over. And I just want to look here real quick. We have just gone the exact opposite direction. I didn't look. I can't really say for sure if you guys did, obviously, because I don't know what you looked at. But I have the sneaking suspicion that if I scroll up, this is exactly what we started with before. I'm pretty sure of it. Yes! Now I changed it, right? I wrote it in a more normal way, but it's the exact same properties. Okay. You obviously need practice with it, but I think you can get practice in the form of a homework assignment rather than practice in your notes if you're cool with that. All right. So, while I'm getting the page and stuff ready, I had my first real fight with Zeke yesterday. We didn't come to punches or anything like that because pretty sure I'd win. But Zeke is starting to get to the point where I can say, let's go. And he's going to say on Alaska or Raiders. Like he's starting to develop that, which is awesome. The Dallas Cowboys played last night. And normally he cheers for the Dallas Cowboys. Unfortunately, last night they were playing Oakland. And if you don't know Oakland's team name, the Raiders. Who do you think Zeke was very, very obnoxiously rooting for during the football game that his dad cares about more than he knows? Oh, that kid. All right, Zeke was cheering for the Raiders, and it still kind of hurts. I like how we have two very different interpretations of that. One laugh and one understanding of the true sadness that's felt in my heart. Nobody knows who it is, but you sound like a monster on these videos, I imagine. All right. I don't think you're a monster, just so you know. All right. It is so hard to not keep making jokes right now. All right. Today is the 18th, and you guys get the privilege of homework 3.3, page 225. And let's check it out. This homework's going to be kind of long, but we get 15 minutes. It's not the 189th day of November. Page 225, and let's see, because there's really two assignments in here. I want you to do 4 through 35 odd. And I promise that it's nowhere near as long as it's going to feel. Like that looks like a lot of problems. But I also want you to do 4 through 35 odd. 5 through 35 odd. My bad. So before it was just 4 through 35 all is what I gave. And then I did it in two assignments, but we're going to sort this out. I also want you to do 49 through 65 odd. I said I want you to do 49 through 65 odd. Well, hold on here. Let's not get too hasty. I swear we did this problem already. Have we done one with decibels already? Didn't we do an intensity of sound in decibels? Dolan sees the exact same problem that I'm talking about. It's the same problem, just with a different point of view. It changed. I guarantee it changed. All right, you convinced me. 97 through 101 odd. No, I heard it. Here's the deal. We have 15 minutes in class. I'm willing to take this on Thursday if need be. Volleyballers, you won't be here to hand it in tomorrow. So I'm willing to take it on Thursday if we need more time. But I'm going to plan on tomorrow. But we're going to just all make sure we all agree that no crying in your bed at 2 a.m. because you have so much math homework. Really, I prefer if you're not crying ever at 2 a.m. But definitely not about math. Cool. Do it. To it.